All right, and we're going to jump back in today with more substitution. As you can see by the title there, Solving with Systems of Substitution Part 2. Now, this is going to be just a little bit more work than what we did in our prior lesson. All right, in our prior, excuse me, in our prior lesson, right, we already had like a y equals, and so we could easily substitute. So what this lesson is going to be about is what do I do if I don't have y equals? All right, so what we're going to do right now, all right, is focus on, all right, how do I solve for a particular variable? All right, so what we want to do, all right, is solve for a variable. So I'm going to do 1a with you, all right, just so you can kind of get an idea here about what we want to do. So I want to solve for y, which means I want y to be by its side on the left side of the equation. All right, so now what that means then is I need to, all right, take care of this guy. So if I want y by itself, I have to make negative 2x 0. Well, once again, you're using that zero property, right? How do I make negative 2x 0? I add 2x, all right, to the left side, and that makes it 0. All right. Now, just like we've been doing with everything else with solving, anytime I do something to one side of the equation, I have to do it to the other side of the equation. So I also have to add 2x to the left side, or excuse me, to the right side, since I added 2x to the left side. Now, here's the thing. That 0, that leaves me just y on the left side equals. Now, 2x and 10 are not like terms, so I can't combine them. So what I want to do is just bring them down as independent terms. So I'm going to bring this down as 2x. All right, and this is a positive 10, so I'm going to write plus 10. So just like that. All right, and so notice now y is by itself, just like it had been in the prior lesson. And so now we could do substitution if we needed to. All right, so now I'm going to do 2a with you and see, so you can see kind of what we do when we solve for x. So we can solve for either y or x. It does not matter. You will get the right answer in the end. What we'll talk about as we go through is when it is more appropriate to solve for one or the other. All right, so now let's look at 2a. All right, this time though, I want to solve for x. So what that means is I need to get the x by itself. So the first thing I want to do, all right, is get rid of this y here. And I want to make it 0. So since this is a positive 1y, so remember there's a 1 in front of that, I want to subtract 1y. All right, that makes that 0. I subtracted 1y on the left side, so I want to subtract 1y on the right side. All right, now bring this down. I get negative 2x equals. Now, once again, 10 and negative 1y are not like terms, so I'm going to write those terms down. Now, I always write the variable term first, but it doesn't matter the order. But this is negative 1y plus 10. You could have written negative 2x equals 10 minus 1y, and that would be equivalent. All right, so the big thing is the sign stays with the term. So since this term is negative, right, the negative has to be with it here or here, whether it comes first or second. All right, now notice, I'm still not finished here because notice the x has this negative 2 in front of it. Now, this is negative 2 times x. So how do we undo multiplication? We divide. So I need to divide this by negative 2, and that's going to leave me my 1x. Now, here's the trick. I have to divide everything by negative 2. So I need to divide this term by negative 2, and I need to divide that term by negative. So now negative 1 divided by negative 2 is 0.5y. 10 divided by negative 2 is negative 5. And so notice now I have solved for x. I have x by itself, or I could get y by itself. So I wanted to go through those two with you, all right, so you can kind of see an idea, because this is a little bit of a new concept. So what I would like you to do now is I would like you to do these 4 problems, right? So solve for y in 1b, solve for y in 1c, solve for x in 2b, solve for x in 2c, all right? Then so pause the video, do that, flip it back on, and then we'll go through that and see how you did. All right, so let's just go through this. So notice if I'm solving for y, I need to get rid of the x term. So I'm going to subtract 12x from both sides. So you should have 3y equals negative 12x minus 9. Then I need to divide by 3. And if I do that, I get y equals negative 4x minus 3. All right, now notice on 1c here, I want to solve for y, but y is on the right side. And so we just go to that side, right? So what do I need to remove from the right side? Is this positive 6. So 6 minus 6 is 0, and then I have to subtract 6 on the left side. Now, once again, negative 3x minus 6, right? These are not like terms, so I'm going to write them separately. You could have written negative 6 minus 3x, would have been fine. Then divide both sides by negative 2. So I get 3 over 2x, and then plus 3. Now, you could have written this as a decimal. That would be 1.5, totally fine. So we either write it as a fraction, decimal, all good. All right, now looking at 2b. Now, this time I'm solving for x. So I want to, all right, get rid of the 3y term. So I'm going to subtract 3y, make that 0. All right, then negative 9 minus 3y. All right, so 3y minus 9, not like terms. I'm going to divide by 12. Now, notice, a negative divided by positive is a negative, a negative divided by positive is a negative, and then I chose to write these as fractions, so 1/4 and 3/4. You might have 0.25 and 0.75, totally fine as well. Now sometimes, right, now notice I'm solving for x in 2c. The only thing I need to do is get rid of the -3 with the x. So I just have to do that division step. So sometimes it's less work. All right, and that's one of the things that might influence which variable do I want to solve for. So I divide both sides by -3. All right, 6 divided by -3 is -2. -2 divided by -3 is positive 2/3, or you might have written like 0.6 or 0.7. Totally fine. All right, so that's how we solve for x or y. Now, how does this, all right, tie into what we've done? All right, so now, all right, if we go back and look at, all right, graphing, all right, so notice when we graphed before, all right, so when we graphed before, right, we said, oh, this is in standard form, I'm going to find my intercepts. All right, so to find my x-intercept, I know y is 0, so I can cover it up. So my x-intercept is 2, so I'm going to put a dot at 2. Then to find my y-intercept, I know x is 0, so that means my y-intercept is also 2. All right, so there's my line. So let me just draw this right here. All right, so there's my line. All right, so this is in standard form. So to find my x-intercept, I know y is 0, so I'm going to cover this up. So -2x equals 1. So I would divide both sides by -2. So my x-intercept would be -1/2. So like right here. So -1/2. All right. And then if I cover up my x, right, to find my y-intercept, -y equals 1. So -1 times what is 1, and that would be also -1. So there's this guy. All right. So now if I draw my line through that, right, and it's really hard to tell if those really do intersect over there if my line is really bad. So this is also just a good example of like why, right, is it we don't always want to use graphing, right? So I didn't have really great intercepts. I didn't draw my lines very well. It's like, do they really intersect? Are they parallel? And so this is why we want an algebraic method. So now let's do substitution, all right, okay, to solve the system. So now, typically when we do substitution, what we want to do is have x equal or y equals. It doesn't matter which one. But I'm going to look for a single variable. So if I have just an x or just a y, that's what I want to solve for. So notice in this equation right here, it's going to be pretty easy. So I'm going to write x plus y equals 2. I'm going to just bring down my second equation here like that. So notice it's pretty easy to solve for y here. I just need to, all right, get rid of the x term. So notice I can subtract, and remember that's a 1x, so I can subtract 1x from both sides. So y equals 2. Now once again, not like terms, so I'm going to write the variable term, -1x plus 2. And so notice, by doing this, now I'm in the same situation we were in our prior lesson with substitution. Now I have a y equals. So what that means is I can now replace the y right here. So -2x minus, now that minus is in front. So I got to put that in front of my parentheses here. Then I'm going to drop in that -1x plus 2. Now I have to distribute. So this is a negative. -1 times -1 is a positive 1x. Negative times a positive 2 is a -2. All right, so there you go. All right, so now when I do my combining like terms here, -2x plus x is -1x minus 2 equals 1. All right, everybody good with that? And then, all right, get this equal to 0. So -1x minus 3 is equal to 0. -1x is equal to 3. I'm going off the screen here, so let me pull that up just a little bit here. All right, and then -1 times what is 3? X is equal to -3. So I must have done something really wrong here. All right, to get my answer. All right, I just must not have drawn my lines very well because they should intersect at -3. All right, so definitely didn't draw my lines very well at all. All right, so that's one of the hard parts about graphing here. And then if I go back to find my y, so remember for finding that solution, right, we have to have the x variable and the y variable. So I'm going to take my -3 and plug it in for x right here. So -1 times -3 plus 2. All right, and so y equals 3 plus 2, so y equals 5. So the solution should have been -3, 5. All right, so -3, 5 right there. So I just did not have a very good tilt to my line there. All right, so you can see why graphing is not, all right, something we want to do all the time, right? You make one small mistake, maybe you don't have the right slant, you don't have a ruler, it's going to be really hard to know that answer. Versus if I do the algebra here, we can get that exact answer every time. All right, so let's flip over here, all right, and let's do, all right, the next problem here. I'm going to grab my ruler, so hold on just one second. All right, so there we go. All right, now I'm back. Got a ruler. All right, maybe my lines will be a little bit straighter. All right, so now, once again, we're just going to graph these and see where they intersect, okay? And once again, if they're in standard form right now, I'm just going to use my intercept method. So I know for every x-intercept, y is 0. So I can cover up y here. So -3 times what is 9? So -3 times -3 is 9. So my x-intercept is -3. Drop my pen, pick that back up. There we go, right there. Now to find my y-intercept, I know x is 0. All right, so 3 times what is 9? 3 times 3 is 9. So there's my y-intercept. All right, so now let's see if I can be a little bit better about drawing my lines with a ruler. All right, there we go. So maybe this will be a little bit crisper, a little cleaner there. All right, now do the same thing here. Once again, in standard form, I'm going to use my intercept method to graph. So I know when I find my x-intercept, y is 0. So -1 times what is 3? -1 times -3 is 3. Oh, well, there's a point of intersection right there, but I want to keep going just in case, right? Because notice what happens here. All right. Okay, I cover up my x to find my y-intercept, and I get y equals 3. So I end up with the same line. Now, hopefully you remember when we have the same line graphed on top of itself, that means we have infinitely many solutions. All right, so now, how would we do this problem with substitution? So let me do this. Now, once again, all right, we get to pick what to solve for, right? So notice the x here has a 3 in front of it. The y here has a 3 in front of it. The x here has a -1 in front of it. But the y here is all by itself. So I would probably solve for this y, and then my next choice would be this x, because it's just going to be a little bit simpler. But I'm going to go ahead and solve for this y. And so I'm going to add x to both sides, like so. That makes that 0. So y equals, I guess I need to put a plus here, so plus x. And once again, these are not like terms, so this is x plus 3. And now I can substitute for my y right here. So notice I get -3x plus 3 times y equals 9. So I can put all of this in for y. So this is x plus 3. All right, now bring that term down. Now I have to distribute here. So 3 times x, 3x. 3 times 3, 9. All right, now notice -3x plus 3x is 0. So I'm left with 9 equals 9. So there's that true statement that we're looking for, right? So that's the algebra interpretation, right? So if I do substitution and I get a true statement, that's the infinitely many solutions, right? If I do substitution and get that false statement, all right, we know that's no solution. All right, that wraps up our lesson on substitution part 2. All right, as always, if you have any questions, bring those with you to class, and I'll see you then.